Okay, let's go ahead and take a look at the reciprocal trig functions. Now we've gone over this section before, but let's review it once more. Now remember that we started off with the basic trig functions, which were sine and cosine, or the cosine and sine. And what we went with after that was tangent, because that was the quotient of sine x over cosine x. And we consider these our basic three. So what happens then is that if we reciprocate those basic three, we come out with what is called the reciprocal trig functions. So we come out with 1 over cosine x equals the secant of x, 1 over sine x equals the cosecant of x, and 1 over the tangent of x being equal to the cotangent of x. Now once we go ahead and establish these reciprocal trig functions, we have 6 trig functions, and those are all the trig functions that we have. Now, one application of the reciprocal trig functions is what we can do with some of the identities that we have. And the primary identity that we have is the Pythagorean identity, which is cosine squared x plus sine squared x equals 1. Now, if we go ahead and divide both sides of that equation by either cosine squared x like we've done here, or by sine squared x like we've done here, we come out with another Pythagorean identity that is based upon the reciprocal trig functions. So in this case here, by dividing by cosine squared x, we come out with 1 plus tan squared x equals secant squared of x. And in this case over here, by dividing both sides by sine squared x, we come out with cotangent squared x plus 1 equals cosecant squared x. Okay, so let's take a look at a couple of examples that we're going to encounter in the homework section. Say for example, if you're given the secant of x equaling 5 over 2, and you know that 3 pi over 2 is less than x is less than 2 pi, how can you find the other 5 trig functions? Now, one way that we can approach this, of course, is using just a very small graph there to describe where these values are coming from. And we know that the secant of x is going to be the hypotenuse over the adjacent side. We also know that the angle is going to be in the 4th quadrant, so therefore we start from the positive x-axis, go in a counterclockwise rotation to the hypotenuse here, and we know that the hypotenuse is going to be 5 and the adjacent side is going to be 2. So by using the Pythagorean theorem, we can go ahead and deduce that we're going to come up with the square root of 21, but being that we're in the 4th quadrant, that value has to be a negative value. So therefore, we come up with the cosine of x equaling 2/5, which of course is just the reciprocal of the secant of x. And then the sine of x is going to be the negative square root of 21 over 5. Now again, remember, those were the 2 basic trig functions that we had, and all the other trig functions can be derived based upon these 2 values here. Okay, let's go ahead and take a look at, say for example, if we want to solve a particular trig function, trig equation that involves one of these reciprocal trig functions. And this one says that you have the cotangent of 2x equaling 1 over the square root of 3 on x from 0 to 2 pi. So again, one of the things that we would like to do is, of course, look for something that we recognize. We know that the cotangent of 2x is the reciprocal of 1 over tangent of 2x. So we can say that the tangent of 2x is the same thing as the square root of 3. Now if we go ahead and take the inverse tangent of both sides, we get 2x is equal to the inverse tangent of the square root of 3, and we know that that's going to be either pi over 3 or 4 pi over 3. Remember also that when it comes to the tangent, the period is going to be pi, unlike sine and cosine, which is 2 pi. And then we're going to multiply that by k so that we can show the periodic nature of this particular function and say that k is going to be an element of z. So when we take a look at this and we inspect this just a little bit more closely, notice that this pi over 3 and 4 pi over 3 differ by a pi, so we can just go ahead and focus on this one here. So if we simplify that, we come up with pi plus 3 pi k over 6. And then after that, it is just a matter of substituting different integer values for k to find out all of the different values of x, which will fall between 0 and 2 pi. And in this case here, if we let k be equal to 0, 1, 2, and 3, we'll come up with solutions for this particular equation here. Notice that k is equal to 4 does not work because it is beyond the domain. Okay, and then the last thing that you need to do, and you can do this on your own, and if you want to take a look at the book will also help you, is just review graphing a reciprocal function given a particular function. Okay, so just to wrap things up again, you start off with your basic trig functions, sine and cosine. After that, we can go ahead and derive what tangent is, reciprocate those, and we come up with the reciprocal trig functions. From there, we can go ahead and look at the Pythagorean identity, and go ahead and include two other Pythagorean trig identities based upon the reciprocal trig functions. And then we have a couple of examples here that will hopefully jar your memory as to how to solve some of these problems. So we'll take a look at some of these problems again when we come to class next time, and let's see how we do. Okay, bye-bye.